counting twice. This topic is actually a bridge between, you can say, PNC and coefficient properties of binomial theorem. We are selecting our students and then making one of them as a leader. If you still try to do it by inclusion-exclusion principle, so this calculation has to give you the actual number of one-to functions, which is 0. Hello everyone, I am Surendra Jain, master teacher of mathematics in Vedantu. In today's session, I will be talking about one very interesting topic, subtopic you can say, but it can be a bit strange to all of you, and I call this as a counting twice. This topic is actually a bridge between, you can say, PNC and coefficient properties of binomial theorem. The properties of binomial coefficient we normally do by comparing the coefficient or maybe some other methods, but here I will tell you how you can write directly the result involving your binomial coefficient using little bit of PNC, some basic PNC. To set the context, I will take two simple examples. One is this. I think we all know the proof, this property, and proof also many of you know. This NC0 plus NC1 up to NCN is equal to 2 power n. To understand both sides of it, please understand, we can assume there are n students. Okay, and they are, let us say, S1, S2, S3, and so on, Sn. Okay, my left hand side says NC0, that says select 0 students out of n. Okay, this NC1 says select 1 student out of n student. And similarly, NCN says select all n students out of n. Okay, so this left hand side is basically number of ways to select none, some, or all students from n given students. Okay, so that is the left hand side. Whereas on the right hand side, we can do it in another way. We can say yes, comma, no, yes, oblique, no to student 1 for selection. Similarly, I can say yes, oblique, no for selection to S2, and so on, yes, oblique, no to student Sn. Now you can see if everybody is said no, 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 then that means there is no student that is selected. That is equivalent to NC0. If you are having exactly one y here, that is equivalent to NC1. This one y where it will go will decide which student is selected. That is same as NC1. Similarly, 2 y's says NC2. And likewise, all y says NCN. So here you can see both sides are doing same thing in different order, you can say. Here we are saying yes, no to all n students, whereas on the left hand side, we are making the cases that 0 number of students selected or 1 number of students selected and so on. So these two has to be equal. So that is one thing. We will be extending this thing to some complex, identities, complex relations of binomial theorem also later on in this session itself. Okay. The second one, please see, NCR plus NCR minus 1 is equal to n plus 1 CR. Very important property. We use this in many questions. But what's the proof? And in fact, sometimes you may get confused where n will come, where n plus 1 come. I think after knowing this proof, you will never ever forget it. Please see, in this case, I am taking n students plus 1 teacher. Okay, so there are total n plus 1 persons. There are total n plus 1 persons. So here on the right hand side, the right hand side says select or choose R out of n plus 1 persons. No distinguished between student or teacher. I think you just have to assume them as a persons. So choose R out of n plus 1 persons. So that is my right hand side. Whereas for left hand side, okay, here I will make two cases. My first case would be the teacher is selected, and second case when teacher is not selected. If teacher is selected and you have to choose R persons, that means from n student you will be selecting only R minus 1 students. Whereas if teacher is not selected, then from n student you will be selecting R student because teacher is not selected. In both scenarios, we are selecting exactly R persons out of n plus 1. Okay, so sum of these two things has to be equal to this thing. That's it. So this is how this property is derived, proved. You can do it by opening NCR also, but I think this is one better way of doing this thing. One more thing, please see this property R into NCR is equal to n into n minus 1 CR minus 1. Here, look at left hand side first. Okay, my left hand side says NCR, that is choose R students. I'm always taking students in the example or in the proof. Choose R student out of n. Okay, that is NCR. But multiplication with R, that means we have to, maybe we can think of that into make one of the selected student as, say, leader or captain, whatever you say. R student you have chosen, So you're having R students with you in a team, let us say, and for that team, you make one of them as a leader. That you can do in R ways. So NCR into R is what we are doing this way. Now on the right hand side, we can think of, because we have to make a leader. So let us choose a leader first. Okay, so N ways to choose a leader. Okay, this is N ways into, now remaining students would be N minus 1, and because already one person that was made leader is also selected, so only R minus 1 are to be selected into N minus 1. C R minus 1 is for what? From remaining N minus 1 students, only R minus 1 is to be selected. Hence, these two sides should be equal. So this is how we can look at these relations. Okay, now I'll come to this relation, which is one very important relation. There has been question in JEE Mains, JEE Advanced on this. And this many of you remember, and I must say that everyone should remember this result. Now I will talk about the proof. We normally do it by differentiation or using this property number 3, which I just talked about, or we reverse the order and we add these two series and we get N common and we get this answer. But I'll tell you another way. Please see this left hand side. If you look at, this is actually summation of R into NCR. R key value R is equal to 1 to N. In this case, you can think of what I told about in this property number 3, that we are selecting R students and then making one of them as a leader. And here the value of R is ranging from 1 to N. 1 to N. That means your team can be of one person, but that person will be the leader. Your team can be of two persons, NC2. Out of these two, one of them will be a leader, and so on. Your team can be of all N persons, then out of N, there will be one leader that will be selected in N ways. So this left hand side says selecting 1 or 2 or so on, or N students, followed by making one of them as a captain. Now the right hand side is what? Please understand. It says select one captain first or leader. Select a leader. I think it is in N ways into from the remaining N minus 1 student, because one is already selected and it is made leader also. From the remaining N minus 1, because I have option of having team of 1 only, team of 2 only, team of 3 only, or team of all N student as well. So from the remaining N minus 1, there is no foundation that I have to choose one student or not, because already one is selected. So I am having now saying yes, no for every remaining N minus 1 student. I think that will be done, N minus 1 times, that is 2 raised to the power N minus 1. I hope that is clear. So this will be equal to N into 2 power N minus 1, and that's a one step. Now, if you understand this thing, 1 into NC1 plus 2 into NC2 is doing what? It is doing like making, first selecting R student and then making a captain out of it. Or we can make a captain first, and then from the remaining student, we will choose 0 or 1 or 2 and so on. So that will be done in 2 power N minus 1. Hence it is done. So that's single step process. You will never forget if you understand this way. Now this property is also extension of what I told you just now. Here it is 1 into 2 into NC2 plus 2 into 3 into NC3 and so on. So this is actually on the left hand side. This left hand side is actually equal to summation R into R minus 1 into NCR, where R starts from 2 to N. Okay. Now in this case, I'll say there is a team of R student. Okay. And from those R students selected, let's say R is equal to 5. One of them will be made as leader in R ways, because you are having all R students with you. And from the remaining, the one is already declared as leader. From the remaining R minus 1, those who were selected, that is made sub leader or sub captain or vice captain, whatever you say. Okay. So NCR to choose R student out of N. Then from those selected R student, make one as a captain in R ways, and make another student as sub leader or vice captain in R minus 1 ways. And if you do the summation from R is equal to 2 to N, it will add all possible teams starting from the size of 2, 3 up to N. Here team of 1 is not possible because 2 person cannot be made leader and sub leader in that case. Now if we look at the right hand side here, first we will be looking at the leader. I think it is in N ways. Then we will be looking at sub leader, that will be done in N minus 1 ways. Okay. And then you are having N minus 2 more students. Now it is your choice, because I am having option of keeping team of 2 only, keeping team of 3 only, and so on. So out of remaining N minus 2 students, you are having, 2 power N minus 2 ways to say yes, no, yes, no, yes, no to all the N minus 2 remaining students. So this way Also, we are doing exactly same thing, which we are doing it in a summation way. So this has to be equal to this thing. I think if you do this way, you will never ever forget these kind of relations. Okay. In fact, if it was r into r minus 1 into r minus 2 into NCR, in that case also it can be written directly n into n minus 1, n minus 2, 2 power n minus 3. Leader you can say, sub leader you can say, and sub leader you can say. So there has to be team of at least 3. And on the right hand side, selecting a leader in n ways, selecting sub leader n minus 1 ways, selecting sub leader in n minus 2 ways. And then from remaining n minus 3 students, you choose or do not choose them in 2 power n minus 3 ways. So this has to be equal. Simple, isn't it? Okay. Now this relation, please see, 1 square, 2 square, 3 square multiplied with NC1, NC2 and so on. Now this relation can be done now in 2 ways. If you remember the result I derived in 4. Okay. So we can write this as r square NCR equal to summation, not 4 actually 5. We can write it as summation r into r minus 1 NCR plus summation, I think it will be r into NCR. So that is the summation of that series where leader and subleader are to be created. So n into n minus 1 into 2 power n minus 1, n minus 2 actually. In this case, it will be n into 2 power n minus 1. If you add them, I think we get n into n plus 1 into 2 raised to the power n minus 2. That is one way. Or you want to do it directly. But actually that will not be directly. It will be similar calculation only. You can think of that I have to choose, let's say r student, summation r square into NCR. Okay, so there are r students that are chosen already. Let's say r is 10. So out of n, 10 students are chosen. Now what is r square? Because we have to multiply same r 2 times. So probably we can say first r is coming from selecting those r students, selecting one leader from those r students. So that one r is coming from there. But next time also I need r. In that case, what I have to think, that sub leader or vice captain can be same person that was leader or captain, or it can be a different person also. So in this case, you will have to make 2 cases. First NCR to choose R student, and then one R to make one person as leader. But another R can only come if you are still having R choices. These R choices means you can make same person as a leader, sub-leader also, or you can make sub-leaders and leader different persons also. So this will be actually same thing. This is the case when leader, sub-leader are different. And in this case, what I will say, you write this as r into 1, which means first person selected as leader in r ways, into 1 means other person, leader, sub-leader is the same person which was a leader. So r into 1 for that thing. Okay, so when leader and sub-leader different plus leader and sub-leader same. Okay, 2 ways. Leader, sub-leader different means it would be n into n minus 1 into 2 power n minus 2, plus when leader and sub-leader same. So first person being selected as leader n ways, second person selected sub-leader is 1 way only, because same person has to be sub-leader. Then into 2 power n minus 1. You can see it is exactly same calculation. So this way you can do it. Or if you remember this kind of result, then by adding also you can get this result. Okay. In fact, I have given you a direct idea of any expression like this. If suppose you are given NCR multiplied with some quadratic. So in this case, you can write it as A into summation r square NCR plus B into summation r into NCR plus C into summation NCR. Here r is starting from 0 to n. In fact, when r is starting from 0, these first 2 will not contribute anything. You can write r is equal to 1 to n also. That's the same thing. So here, if you remember these results, which I strongly recommend you must. So it will be n into n plus 2 into 2 power n minus 2 plus B will be multiplied with n into 2 power n minus 1, and the C will be multiplied with 2 power n. In fact, if you are looking for what will happen if I get r cube NCR. Okay, here either you can make 3 cases, that leader, sub-leader, sub-sub-leader, all 3 different, 2 same, or third different, or all 3 same. Those cases you can make. Or if you're not very comfortable, then I will suggest you write it as r into r minus 1 into r minus 2. I'm writing this r cube. Okay, so r cube is already there, but I have subtracted by minus 3r square. I think this minus r 2r multiplied with this r, so I have to add 3r square. So instead adding 3r square, I will be adding 3r into r minus 1. Now look at the term of r. I think 2r was here and minus 3r was here, so I have to add once r here. So this thing multiplied with NCR. Now we know how to write the answer for r into r minus 1 into r minus 2 multiplied with NCR. I think that will be n into n minus 1 into n minus 2 into 2 power n minus 3 plus the next term 3 times r into r minus 1 multiplied with this. It would be 3 into n minus 1 into 2 power n minus 2. And the last one would be just n into 2 power n minus 1. So just simplify these things. I think you will get the result for this also. It is not that common to remember, but if you know how this can be clubbed with these three things, I think it is not very difficult to figure out it. Okay. Now this identity where 1 is divided, 2 is divided, 3 is divided, this is normally done by integration, or maybe that property number 3 which I discussed here in the session. This, let me tell you, if you do it by counting twice, it is not that obvious or direct as it was there for identities before it. But we can still derive it. Still, I'll say that if you're not comfortable with this method of counting twice, you continue with your normal method only. To derive it using counting twice principle, what I will do, I will multiply n plus 1 here, and I will write this as NCR upon r plus 1, and this r will start from 0 going till n, and we have to prove 2 raised to the power n plus 1 minus 1. Now, to derive this, what I'll do, I will assume there are n plus 1 students. On the right hand side, I'll do first. Okay, right hand side is actually equal to number of selections of at least one student from n plus 1 student. Suppose we are having n plus 1 students, okay, and I have to choose at least one. Then saying yes, no in front of all of them will give you 2 power n plus 1 ways. And one way will be when we are saying no to all of them. So 2 power n plus 1 minus 1 will be number of selections of at least one student from n plus 1 student, that is right hand side. Now let's talk about the left hand side. Okay, now please understand this left hand side is done. N plus 1 is already multiplied. Now we said at least one student to be selected. So let us say we have selected that one student first. Okay, so select one student first. And that will be, I think, in n plus 1 ways. That will be done in n plus 1 ways. Okay, now we are free to take 0 or 1 or 2 students from the remaining n students. So we will be multiplying by NCR, and there will be summation also on this. Okay, into NCR, R will be from 0 to n. You can choose 0 also, you can choose 1 also, you can choose 2 also, and so on. But there is a problem in this process. Try to understand that. I'll take example of R is equal to 2, let us say. Suppose r is equal to 2 is there, and in the beginning the student we selected was, let's say, S1, and later on you chose 2 more students from remaining n students, and we got S2 and S3. Okay, so 1 student in the beginning and 2 students later, so we selected S1, S2, S3. But this could have been the same selection if in the beginning, instead of S1 in this n plus 1 ways, I selected S2, and later on I select S1 and S3 in this NC2. Okay, and similarly if I choose S3 here and S1, S2, then also you will have same selection, but this thing is actually counted 3 times. 3 times. Why 3 times? Because S1, S2, S3, I think in the beginning itself I'm saying n plus 1 ways, so these 3 are different ways here. And then NC2, when we are choosing this or this or this, the same selection is actually counted 3 times when R is 2. So what will happen if you're choosing R student after 1 is selected in the beginning, there will be a repetition of R plus 1 times. So we have to divide it by R plus 1. So that's why this will be, left hand side will be equal to n plus 1 into summation NCR upon R plus 1. So that's it. I hope you have understood it. If you have not, try to, listen to this video once again, maybe just 1 minute or 2 minutes before it, and you will be clear. But still I'll say, if you're not that comfortable because I have to multiply here and there is some repetition also, then continue with your older method, that is integration method, or that coefficient method, that property 3 I discussed here. Okay. Now one more example, let's take more example. That is a very famous Vandermonde identity where NC0 square plus NC1 square and so on, NCN square is 2NCN. Okay, now how this can be done? Please see, this is one very interesting thing and I'm sure you will like it. In this case, what I'll do, I will write NC0 as NC0 into NCN. We know NC0 and NCN are same. Similarly, I will write NC1 into NCN minus 1, NC2 into NCN minus 2, and so on. In the last, it is NCN into NC0. You can see the numbers written here, they all are such their sum is equal to n. Now, I'll create one analogy. Please see. I will take n number of girls and I'll take n number of boys. Okay, so there are total 2n persons. 2n persons. My first term, that's T1. It says 0 number girls selected, 0 girls selected, plus n boys selected. Out of n girls, 0 girls selected. Out of n boys selected, NCN ways. But term T2 says, T2 means this one. It says 1 girl selected and n minus 1 boy selected. And so on. The last term, that would be Tn plus 1. It says n girls selected and 0 boys selected. So you can see that my left hand side is actually counting all those cases which are possible when you are going to select exactly n persons out of n girls and n boys. 0 to n, n to 0. But if you consider them as a persons, 2n persons, and you have to choose n, I think this has to be equal to 2n Cn. Because in 2n Cn, I think there is no other case that is left out after these n plus 1 terms. So this has to be equal to this 2n Cn. Okay, so this is direct. There has been use of this identity in many questions. In fact, more general thing is this thing. And also after this, one more identity I'll show you. In this case, what is happening? They are not same. Their difference are same. 0k, 1k plus 1, n minus k, n, and so on. But I can write this as ncn, nck. This would be ncn minus 1 into nck plus 1. If I write this way, you can see instead of difference that was k, now the sum is becoming constant, that is n plus k, n plus k, n plus k. Once again, same analogy. Take n girls, okay, n boys, n girls, n boys. My first term, T1 says we are choosing n girls with k boys. My term 2 says we are selecting n minus 1 girl and k plus 1 boys. Okay, and so on. And I think this is n minus 1. So which term it should be? I think I started with 0. It was n minus k. So it will be n minus k plus 1. N minus k plus 1 term would be when we are selecting k girl and n boys. Okay, so you can see every term is giving you n plus k selections out of 2n persons. Out of 2n persons. Now, if 2n persons are there and you are selecting n plus k, I think this will be directly 2n c n plus k. And when you are selecting n plus k total persons, I think these are the cases if we are having n girls and n boys, no extra cases there. Whenever you think there is some term was there which is not written here, it should have been there, I think you have to subtract that particular term from this final result. In fact, that has to be done if you are using coefficient method also. Okay, so this will give you exactly same thing. But now I think it is very easy to say that in the whatever is written in the superscript like n, it has to be added, so 2n it will become, and whatever sum is here, because here difference was constant, so first we have to change it so that your sum becomes constant. So in this, the sum will come like n plus k, and later on you can convert it as 2n cn minus k also as per your wish. Okay, I think next thing is exactly same thing. Here m and n are different, so here you have to take m girls and n boys. Okay, this I'll write MC0, I'll convert to MCM. I will write this as MCM into NCK. I'll write this as MCM minus 1, NCK plus 1, and so on. So you can see every time we are going to choose m plus k persons out of m girls and n boys. So there can be two ways. One, making cases. So term 1, term 2, term 3 are counting all those cases. And on the right hand side, if you do it directly, it has to be m plus n c, and it would be m plus k. That is the outcome. So very simple, isn't it? Okay, let's do some, one more thing, then I'll come to previous year questions, bacho. Please see, in this case, what is happening? We are doing two things. We are squaring also, and we are multiplying by one number also. So how to deal with this? I think we can, combine two things here. One, that girl boy, and one making one person as a leader. So please see how we can do it. I think the first term I can write it as 1 into NC1 into NCN minus 1. Then 2 into NC2 into NCN minus 2 plus 3 into NC3 into NCN minus 3 and so on. And the last term is n into NC0 into NC. I'll write NCN here and NC0 here. Okay, this is increasing thing, so n here. Now, how I'll create the analogy of RHS and LHS. Here I'll take again n girls and n boys. Okay, now please see. My first term says, term 1 says choose one girl and n minus 1 boy. And then make the selected girl, make the selected girl as a leader. Selected girl as a leader. Okay, because we are multiplying by 1 here. So only one girl is there, so only one option is there. But term 2 says 2 girl plus n minus 2 boys to be selected, and then make one of selected girl as leader. Because 2 girls are selected, so you will have 2 choices whom to make as a leader. So you will be multiplying by 2. Similarly, if you look at the term 3, you will be selecting 3 girls. So to make a leader from girl, you will be having 3 choices. So 3 into NC3 into NC n minus 3 and so on. This one would be selecting all n girls, no boys. So from n girls, you have n options to make whom as a leader. So n into NCN. So this left hand side is actually like, selecting some girls and remaining boys. So that total selection is of n persons. And whatever number of girls you have selected, from them you have to make one of them as a captain. The right hand side is now direct. I am sure you must have understood it by now. N is for choose a girl whom you want to make as a captain. Girl who is captain or leader. Okay. And into from remaining 2 n minus 1 person, which includes n minus 1 girls and n boys, you have to choose only n minus 1 persons. So this is for selection of remaining person. I will not write it. I think that is very much clear. So this way, these two sides are equal. And I'll now come to the question. And my very first question I have taken from 2018. And this question is directly based on what I have just done now. Okay. I think there is nothing I need to do. It will be directly, can I say that? 10C1 square plus 2 into 10C2 square and so on. So you can assume 10 girl, 10 boys. Okay. One girl to be selected as a captain, and from remaining 19 you have to choose, I think, 9 people. Total was 9 here. My previous identity example analogy, we can say it directly. So this would be 10 into 9c 10 into 19c9, and that is equal to x. In this question, the most difficult part was to find the value of 19c9. Not very difficult, but a calculation was lengthy, because 19 factorial you have to write 19, 18 till 11, because in the denominator you are having 10 factorial, 9 factorial. So these terms will be written, I think, 9 or 10 times, that you have to multiply, or you have to cancel from denominator to numerator. So that was a big task to do this question. Else, if you know this thing, or by coefficient method also, this question was not that difficult. If you simplify it, I think it comes out to be 646. Calculation I am skipping for you. Please do it. Next question, bacho, please see this question. This was a question of 2019. Okay. So here you can see there is a determinant. First term, I think we all know it is n into n plus 1 upon 2. That second element of first row, I think we know it now, n into n plus 2 into 2 raised to the power n minus 2. You must remember this result, or you have to derive it every time. The first element of second row, it is n into 2 power n minus 1, whereas the last one is 4 power k. I think this is just the binomial expansion of 1 plus 3 whole power n. You can check. If you do the expansion of 1 plus 3 whole power n, this will be exactly this summation. So this is what we are getting, and we are given this to be equal to 0. Now you open it. I think we can take n into, here it was n plus 1, not n plus 2. So here I can take n into n plus 1 common from the first row, and then it will be this 4 power n by 2 minus this 2 power n minus 2 multiplied with n into 2 power n minus 1 is equal to 0. You can simplify it. You will get answer of n to be 4, and then we have to find summation k equal to 0 to n nck upon k plus 1. So same identity which we have discussed in this session also. You must remember these results, bacho. So it will become 2 raised to the power 5 minus 1 upon 5. So this is 31 upon 5. So it is 6.2. 6.2 is the answer. Okay. So these two questions, I hope they are easy, not difficult. Now this question was a bit tricky, I'll say. Trick was, in creating this GM function. Okay. So we are given first, we are defined as SCR. It is nothing but NCR only. Okay. And then we have to find out GM comma N, where GM comma N is consisting of f of m comma n comma p. So first we have to simplify for f, and then we will go to this G, and then we'll answer some questions. So let's first simplify for f m comma n comma p. Okay, in this case we are given summation. In this m c I, you don't have to do anything for this. For the other term, if you expand, so it will become n plus I factorial upon p factorial into n plus I minus p factorial into, that will be p plus n factorial, that will be p plus n factorial divided by p minus I factorial into, if you subtract it, it will be n plus I factorial. Okay, this n plus I factorial and n plus I factorial are getting cancelled. Okay, now here p plus n, because this summation is for I equal to 0 to p. So you can bring this p plus n factorial outside. You can bring this p plus n factorial outside. And if I write p factorial n factorial here, okay, this p factorial is already there. So this is gone outside. Now please see, mci is here. This n factorial I have to write here. And the remaining factorials are n plus I minus p factorial with p minus I factorial. Okay. Sum of these two, if you check, it is n only. P cancels, I cancels, so n. So I can write it as, this would be p plus n cp here outside, summation mci into, I can write this as nc p minus I. Okay. Now the identity which I was talking about just now, I is equal to 0 to p. Okay. So we are keeping all possible values of, I here from 0 to p, because this mci will not be defined if I is taken any value lesser than 0. The value of this starts with 0 only, and here also if I take highest value of I, so this will take value 0. So that means all possible defined mci nc p minus I can be there, they are taken care of here. So I can write it directly. I think this I was talking about as m girl, n boys, and you have to choose total p number of persons. So this will give you p plus n cp into m plus n cp. Okay, so I think this is what we are getting for this thing, f m comma n comma p. Okay, now if I use this and if I put it here, okay, in g m comma n, in this g m comma n, we will be getting as, if I put this as p plus n cp into this thing, so n plus p cp will be cancelled and we will be getting m plus n cp. Okay, now using this, where m comma n, this was m comma n, sorry for my writing, but I think it is not that bad. So g of m comma n, we got to be m plus n cp. And one more thing, I think I'm making one mistake. Yeah, I'm making a mistake. Actually, this has to be summation of this thing. Yeah, this has to be summation of this thing, where p is starting from 0 to m plus n. I think we know this property. It is directly 2 raised to the power m plus n. Okay, so this g m comma n is actually summation of this thing, which gives you 2 raised to the power m plus n. Now you just have to see what should be, you can see what should be the right answers. I think A option is obviously correct. B option is also obviously correct, because m or n, whatever sum is there, that matters to find the value of g of m comma n. Similarly for D also, I think this seems correct. C is wrong. So answers for these questions are A, B and D. Okay, moving to the next thing. I have taken few more examples to complete this session, and one of them is this thing, where we are given 3c3 into 11c4 plus 4c3 into 10c4 plus 5c3 into nc4 and so on till this. Now here if you see, the number written in the superscripts are changing, but they are changing so that their sums are same. 3 plus 11 14, 4 plus 10 14 and so on till the end. Okay, whereas numbers here are same. So how we can do this? To do this by coefficient method, you can do it. It's a lengthy process. In fact, you can do it by binomial expansion also for any index where power is -1 or -2, something like that. But I'll tell you again this method counting twice. Please see here. I'll remind you first that suppose you are given n coins and identical coins, and there are r beggars. Okay, so how do we distribute these coins into r beggars? I think there is a direct formula, n plus r minus 1 cr minus 1. Okay, now if you look at these, here we are having 3 3 and here 4 4. So maybe I can do something with this and some multiplication, and then we will be able to get the answer. Please see how. If you look at these 3 4, so it looks like I should be having 4 beggar at one place. Okay, and I should be having 5 beggar at one place. You can assume there are 4 beggar on one side of the road and 5 beggar on the other side of the road. Okay. Now when it is 3C3, it is actually when you are giving zero number of coins to these 4 beggars which are sitting on the one side of the road. Whereas when 5 beggars are there and it is 11C4, in that case R minus 1 is 4, so I think this n should be equal to 7. So 7 coins should be given to those side of road actually where 5 beggars are sitting. Okay, now you can do it once again. 4 plus 0 minus 1, so 3. 3C3 gives number of ways to distribute 0 coins to 4 beggars, and this 11C4 is actually says distributing 7 coins to the 5 beggars, so it is 11C4. Now if you change 1 coin here and make 6 coins here, you can see it will give you the second term. Similarly, if you do 2 coins here and you make 5 coins here, you will get third term, and so on. For the last term, I think it will be 7 coin here and 0 coin here. So you can see that if I am having total of 7 coins with me, there can be 2 ways to distribute them among 9 beggars, considering 4 of them sitting on the one side of road and 5 sitting on the other side of road. And then on one day, maybe you say 0 this side, 7 this side, 1 this side, 6 this side, 2 this side, 5 this side, and so on. Or you consider all the beggars as a group of beggars of 9, and you are having total number of coins as 7. So you can think of 7 coins plus 9 beggars. Okay, so this will be 7 plus 9, 16 minus 1, 15C 8. Or you can write this as 15C7 also. So this left hand side is counting those cases when we are considering beggars on 2 different sides of roads, and cases of 0 coin this side, 7 coin this side, and so on. Whereas the right hand side is considering when all beggars are together and we are distributing them 7 coins in one go, you can say. So they have to be same because this is counting all these cases only. So this is how we are getting the answer. I think 15 plus 8, 23, or 15 plus 7, 22 can also be the answer. Okay, so that is that question. Now one more question. I think I am having 2 questions after this, including this actually. So this is NC0 square upon 1 plus NC1 square upon 2, and so on. This question again, I will suggest that you do it by integration and coefficient method. But I'll tell you that counting twice method also, please see how we can do it. Here, because we are having division of 1, 2, 3, and on the right hand side 2n plus 1 c, n plus 1 upon n plus 1. I'll go with that, let's say n plus 1 girls and n boys. Okay, so n plus 1 girls and boys, so total there are 2n plus 1 persons. There are total 2n plus 1 persons. Now out of 2n plus 1 persons, select n plus 1 persons. Select n plus 1 persons, and that will be done in how many ways? 2n plus 1 c n plus 1. Okay, now because we are selecting n plus 1 persons, so there has to be 1 girl at least. You cannot do this selection without having at least 1 girl in this selection. Okay, so that is 2n plus 1 c n plus 1. In fact, here also I will take this n plus 1 multiplied on the left hand side. So you just cancel it from here and multiply this n plus 1 here. So it is very much similar to that we did earlier. Now this is 2n plus 1 c n plus 1 ways to select n plus 1 persons from these 2n plus 1 persons, where n plus 1 girls and boys. Now because at least 1 girl is always there, which is understood. So this left hand side you can think of the first select 1 girl. Okay, and that will be in how many ways? I think n plus 1 ways, because there are total n plus 1 girls, so n plus 1 ways to select that girl. That has to be there. Now after that, this nc0 square, I will write this as nc0 square. I will write it as nc0 into ncn, which says now from the remaining 2n persons, from the remaining 2 persons, then from remaining n girls and n boys. Okay, either choose 0 girl and boys, so nc0 into ncn, which is nothing but nc0 square, or you choose nc1 square, which I can write it as nc1 into ncn minus 1, or you choose 1 girl from the remaining n and n minus 1 boys. Okay, but the problem here is, as I have explained earlier, that when you are choosing 1 girl later and 1 girl is already chosen in the beginning, there will be repetition. Why repetition? Because which girl you have chosen in the beginning, let's say G1, and then second girl you have chosen later on, that let's say G2. This could have been G2 first and G1 also. G2 first and G1 also. In this case, you can see this will be counted twice, so you will have to divide it by 2. Similarly, when it is nc2 square, then it will be like 1 girl is already selected in n plus 1 ways. So 2 girls later on selected and n minus 2 boys selected. But for those 2 girls selected, I think there will be a repetition 3 times. So divide by 3. And similarly for this also. So you can see this 2n plus 1 cn plus 1 is equal to n plus 1 into this thing. Okay. Now you may say, sir, how can we think that way? If you are not comfortable with this kind of ideas, I will suggest that you stick to your integration method, or maybe after going through this session, you can practice a little bit and try to see, that how can we use these ideas in more questions. If you're not, try with maybe 1 minute or 1 and 2 minutes, and then you can switch to your ordinary methods if you're not comfortable at. Okay, so that is that question. In fact, let me tell you, bacho, it is not only limited to binomial thing only. This can be done in other places also. In fact, binomial coefficient thing is coming here itself. Now this identity, please see, where ncn, n power n minus nc1 into n minus 1 power n and so on, we have to prove is equal to n factorial. In such question, actually we have to think of some ideas like group formation, or some inclusion exclusion principle, beggar coin, or number of selections, making a leader, or something like this, like that. In this thing, what we are going to do, I'll assume there are 2 sets. One set is A and one set is B. Okay, now this is 1, 2, 3 having n elements up to n. This is also having 1, 2, 3 up to n elements. Now I want to make a function a to b which is 1, 1 and onto. Obviously, if it is 1, 1, it will be onto also. Rather, I'll say onto first and then I'll say 1, 1. I'll say onto, then I'll say 1, 1. Okay, so I want a to b functions which are onto. Obviously, it will be 1, 1 also. So directly it has to be when all elements are having all these elements are having only one pre-images. So it will be done in n factorial, which is my right hand side. But if you do the same thing by inclusion exclusion principle, so how we can do it? We can first make the total number of functions, that in this one will be having n choices, 2 will be having n choices, so n will be multiplied n times. But obviously in this case many elements will be left out. So what we will do, we'll subtract those cases when let's say one element is left out. Which element is left out? Maybe 1 is left out, or 2 is left out, or 3 is left out. So NC1 ways to choose that element which is left out. Now after, let us say 1 is left out, this 1 will be having n minus choice, 2 will be having n minus 1 choice. So everyone will be having n minus 1 choices n times. Okay, so that we have subtracted. Those who knows about inclusion exclusion principle, in this case we are over subtracting those cases when not only 1 is excluded but 2 is also excluded. That is counted actually 2 times here. One when you were excluding 1 in the beginning, and then later on 2 was excluded, or then when 2 was excluded in the beginning and 1 was excluded later. So this kind of cases are counted, or you can say subtracted multiple times. So to take care of that, we do plus minus plus minus. That is the fundamental behind the inclusion exclusion principle. So if you do plus, so it will be nc2 into n minus 2 raised to the power n, because if 2 elements are taken out, then only n minus 2 choices will be there for every element here. Then minus nc3 into n minus 3 raised to the power n, and so on. So you can see this left hand side becomes equal to n factorial like this. There can be many questions that can be formed with this. Suppose instead of n element here, if it was having n plus 1 element, suppose if this b was having n plus 1 element, then I'm sure you can understand you cannot have onto functions, because at least one element will be left out. In this case, if you do the similar calculation on the left hand side by inclusion exclusion, this has to be equal to how much? I think 0, because if number of elements are n plus 1 here and n elements here, you cannot have onto functions. So if your b is having more number of elements than a, you cannot have onto function. But if you still try to do it by inclusion exclusion principle, so this calculation has to give you the actual number of onto functions, which is 0. If you keep number less here, more number here, then also you can get this kind of identity, but in that case your right hand side will also have to be calculated. It will not be direct. Okay, so this is all for today, bacho. I think this was my last slide. Yeah, so I hope you will like this session. You would have liked this session. Please go through the notes I have shared with you, and if you have not understood anything in this session, I'll request you to go through once again to that part and see what I am saying there. So thank you so much. Bye everyone. Take care.